Topic 10-3. This can be referenced in our whole textbook, chapter 12, section 7. It actually starts on page 873 and 874. Talking about dilations. If you'll, the graphs we're going to do, we're actually going to use slope to make these dilations. And just remember, dilation can be either getting larger or getting smaller. If it's getting larger, it's called an enlargement, and if it gets smaller, it's a reduction. So let's go through example 1 using the graph to find slope. Review from algebra that slope is the rise over the run, and you're looking at the slopes of all the different lines. The first one they want is line A, and that's this one here. So you find a point on the line, and you're going to use the graph. So we were just going to walk up 3 and over 2. Remember, you use your rise movement first. Here's an example. That's the up or down movement. Run is the left or right movement. So the slope of B, which is this one right here, take the point, you're going down a -1 and then over a +3. So -1/3. The slope of line C is undefined. When it's straight up and down, it has an undefined slope. And that always will cross your x-axis. The slope of a line that crosses the y-axis has a slope of 0. So always remember, your horizontal lines have a 0 slope. Oh, that's a cute way of remembering it. Horizontal has a 0 slope. If you're ever seeing y equals a number, then that's always going to be a line like this. If you see a x equals a number, it's going to look like a line that looks like this line C, when there's no other variable with it, just a whole number. When given the coordinates of 2 points, the slope can be found using the formula m. M is your slope. You're taking the change in y's over the change in x's, oftentimes referred to with a triangle like that. The change means the subscript really is just making sure you keep your coordinate points together. If I start with a coordinate point y, then making sure that I divide by starting with the same coordinate point. So if it helps, number them when you're actually asked to find the slopes. x1, y1, x2, y1. Just keeping in your mind that x is your first value, y's are your second values. The little subscripts can help if you're using the formula and you want to start with the same. So it's 2 minus a -6 and 1 minus a -2. Well, minus a negative makes a positive. This had started out with 2 negatives, but then you add the opposite. This was a 1 minus a -2. You add the opposite. So that becomes a slope of 8/3. So example 3 is done the same way. You've got 2 points. Plug in the formula and be careful and make sure you remember to reduce. If you have 2 even numbers, you always know it can be divisible by 2. You can divide a -6 by 2, and you can divide a 4 by 2. And that's where we get the -3/2. So reviewing slope will help us in our next 2 examples of dilation. Okay, so the slope can be useful when you're trying to dilate a figure. In this one, the slope is use slope to produce a dilation of triangle ABC with a scale factor of 2. Use B as the center. So if B is the center and I'm moving out this way and this way, and I'm going to make this triangle twice as big, because the scale factor is to multiply of my points by 2. Well, the easiest way to show this is using slope. If you start at B and you use the slope formula of walk down 2. How many did I walk over to get to this point? Count spaces. 1, 2, 3, 4. I'm going to go down 2 over 4 again. So I've just done the slope movement twice because the scale factor was to get 2 times bigger. You can use distance formula from B to A, and then from here and here again, making it the exact same distance to move it, but it's so much easier to just use slope. So my new A, it was here, and now it's at -7, 1. That would be my A asterisk. Make sure you remember it's the A asterisk was creating the new point. Alright, likewise with point C, from B, I walked down in a different color. It looks as if your slope is 1, 2, 3. You're going down 3 over 1. Down 3 over 1. So I'm creating twice as big. That's what's shown here with the 1s and 2s. And then my new point for C is +5, -1. Coordinate points. Remember when you're naming coordinate points, X and then your Y. And notice what happened. My triangle was enlarged when the scale factor is greater than a 1. But on example 5, they're wanting us to use slope to produce a dilation of XYZ half as big. So in the final product, we've highlighted it, shaded it to show that it's going to reduce by half. So if we started out with from X to Y, I've walked down 3 and went over 2, so I'm going to go down 3 and over 2. Actually, I'm sorry, we went half, so that's down 6 over 4. So halving 6/4, that's where the reduction comes into play. You started with 6/4 and then you reduced it by a half. So you're dividing by 2. So again, from X to Z, you went down 2 over a +1. So again, you would go down 2 over a +1. Your new points, your original points are here, and your new points would be there. That concludes example 10-3.